Okay, so this is one of the coolest things. It's, in my opinion, like a beautiful move to be able to make in calculus. Like, it's elegant. It's a really cool process. So it says a differential equation is an equation for the derivative of y in terms of x and y or other values. Okay? The big idea here is that differential equations are when you are given the derivative. You are given the derivative of a function. Okay, so we spent the better part of the first semester finding the derivative, right? In this particular problems, they start off with that. It says the following are examples of differential equations. So if you look there, you can see a whole bunch of different differential equations. One way that this might show up is as y prime. Okay, y prime equals whatever. I have seen them say something like, show that this is a solution. And you have a y prime equation, and you're supposed to find y double prime. You're supposed to find y. Okay, lots of different ways to go with this. But keep in mind that y prime is a derivative, just like dy dx or dh dt. Okay, those are all derivatives. Given a differential equation, the AP exam could ask you to do several things from this one equation. You could sketch a slope field, which we've done. You could sketch a solution curve given a slope field. We've done that. You could write an equation of the tangent line. What are the two things you have to write an equation of a tangent line? A point and a slope, right? What's the diff EQ part of that? When they give you the differential equation, what are they giving you? That's your slope, right? And you can plug in your point, find the slope at that point, go from there. You could be asked to find the second derivative. And that's what I was saying about this y prime business. I've seen them say, what's y double prime? You could determine relative extrema at a given point. How would you do that? How would you find an extreme value given a slope? Set your differential equation equal to 0 and solve. Go figure out where that happens. You could find vertical and horizontal tangent lines. In my mind, that's kind of asking the same thing. Horizontal tangent line, extreme, right? Vertical tangent line, if it's rational, you would set your denominator equal to 0 and figure out where your function's undefined. Where does that happen? This is what we're talking about today. Find general or particular solutions to the differential equation. So we're going to find the equation for the solution. Instead of looking at the slope field and trying to draw the solution, we're going to actually find the solution, the equation that would have yielded that particular slope field. Does this make sense? A lot of times you have to have the initial condition to do that. Because otherwise you're finding an equation that could be graphed anywhere, right? That's where the plus C part comes in. It could be located anywhere on the slope field. So they're going to give you, find the solution that goes through this point, this initial condition specifically. Am I just rattling words that y'all are not? Yeah, a little bit. Okay, let's just try it. This means that given dy dx, given the derivative, we need to find the equation y equals f of x. Lauren, do you want some of these papers?
I have them. They're just at my house.
Do you want a new one?
It's okay. I'll just take a picture of it.
Okay. This requires integration, but we must do some work first because our derivatives are going to involve both x and y. So what they're saying is if you look at these equations up here, you see that they have 2xy, they have 2h over t squared. You've got both variables in that differential equation. So that's problematic. In AP Calculus, the only differential equations we will be asked to be solved will be separable. Separable. That's the word here. Separable. Meaning we can separate the variables. We can split up x and y. This means we can separate the dy and the dx through only multiplication. That's going to be the move that we make here. So our first example here, example 1, says, given this differential equation, 2x times y plus 3, separate the variables. That means get all your y stuff on one side and all your x stuff on the other side. Are y'all following that? So how am I going to get dx to go to the left side? Or go to the right side. Yeah, I don't know right and left. This is confirmed. Multiply both sides by dx. So yeah, those can separate. So interesting. Multiply both sides by dx, and you'll get rid of that. So you end up with dy equals 2x times y plus 3 dx. And now we want to move the y stuff to the left side. We want to separate the variables. So what? Divide by that y plus 3. Like I said, it's a pretty elegant process. I like it. So dy over y plus 3 is equal to 2x dx. We have separated the variables. Okay? Not so bad. Everybody okay so far? Lily, you breathing? Is that it? That's the separating the variables piece. Separate the variables, right? Now, how do I use that to find a solution? So what we have is something dy equals something else dx. And we want to solve for y. We have a dx and a dy. How do we solve for y? Dx and dy meaning like a derivative. How do we undo we integrate? You can undo the derivative by integrating. They're your inverse operations. Okay, so it says we want to multiply both sides of the equation by dx. We just did that. We want to separate the variables by multiplying or dividing if necessary. We always want y on the left and x on the right. We're going to integrate both sides. Integrate both sides. Be prepared to use u sub. It could happen. It will happen. Then we're going to use the initial condition, and this is where that plus c business gets handled. Use the initial condition, okay, because we can find a general antiderivative, but we don't want a general antiderivative if they're telling us it's got to go through this point. Then we got to use that point to nail it down. Y'all understand? Solve the final equation for y, meaning get y by itself. All right, so here we go. This is example 2. They say consider the differential equation dy dx equals x plus 1 over y. Find the particular solution, y equals f of x, given the initial condition 1 equals negative 4. F of 1 equals negative 4. So our first move here is going to be separate our variables. We're going to take dy over dx. I was about to write out steps for y'all. Fun fact, he just did that. dy over dx equals x plus 1 over y. We're going to multiply both sides by y, and I would multiply both sides by dx. In other words, cross multiply. Right? So we end up with y dy equals x plus 1 dx. And we have separated the variables. After you do that, we're going to integrate both sides. Integrate both sides. And this is going to undo the derivative part. And we're getting back to the function. Remember, the integral of the derivative is the function.
So it removes dy and dx?
Uh-huh. Integrate both sides. So we integrate y, what do we get? Y squared over 2 plus c, yeah? Okay? Don't put it. I'll tell you why in just a second. We are going to put it, but we're going to keep it on the right side. Because what I would do here, if I was going to have to solve for y, is I would swing it to the right side. Well, what's an arbitrary constant minus another arbitrary constant? Say an arbitrary constant, c. Okay, so because we don't know what number that is anyway, we're just going to put it on the far right. We have to acknowledge it, but we don't have to acknowledge it on both sides. We don't even know what that number is. Why would we want to do it? Equals
1x or y.
plus x. Yeah, 1x, or just x. Plus c. Okay. And there's a big pro tip that I have for you right now. Always, 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 you're going to plug in your initial condition in this step. As soon as you've integrated and you wrote plus c that first time, now we want to solve for c. You don't want to solve for y and then plug in. That gets super nasty a lot of the time. So we want to go ahead right now and plug in and find out what c is and then go back and solve for y. So plugging in, we're going to go -4 for y equals 1 for x get 8. 8 equals half plus 1 is 3/2 plus c. 8 minus 3/2. What's that? 8 is 16/2. 16/2 minus 3/2 would give me 13/2 equals c. Is that okay with y'all? So now we go back to our y and x equation. Y squared over 2 equals x squared over 2 plus x plus 13/2. And we're going to solve that equation for y. So multiply both sides by 2. So y squared equals x squared plus x over 2 plus 13. If I multiply everything through by 2, only the middle term has the half in there. That would be 2x, not x over 2. Better. And then we're going to square root everything. So y equals plus or minus the square root of x squared plus 2x plus 13. And remember, our solution should be a function. So we're going to have to pick between plus or minus. How do we pick? We flip a coin. What is the point that this has to go through? 1 comma -4. So if it's got to go through 1 -4, what does that mean about this square rooty business? I want the bottom half. It's got to go through -4 on the y-axis. Is that clear? So we're going to have our solution is actually y equals negative square root of x squared plus 2x plus 13. And it's negative again because it's going through 1 -4, which is going to be the bottom half of that. What do you think? We like? Okay. All right, so example 3, we've got a new differential equation. Find the particular solution through the point 2, 1. So this is just more practice, okay? Nothing new here. Separate the variables. I'm going to divide both sides by y and multiply by dx. And so I end up with dy over y equals 2x dx. Last year, my crew really had a hard time seeing dy over y and knowing what to do. They did a lot better if we would write it as 1 over dy, or 1 over y times dy. It's the same thing, but they preferred. So you could say 1 over y times dy. That's the same exact thing. So how do I integrate 1 over y? Natural log y. And this is going to be the absolute value of y because we cannot natural log a negative number. So natural log of the absolute value of y equals It'd be 2x squared over 2, so just x squared plus c. And at this point right here, you plug in. So I'm going to switch colors so I know this is plug in time. So natural log of y would be 1 equals 2 squared plus c. Natural log of 1. So when x is 1, 0. Very nice. Y'all know stuff. I'm proud. 0 equals 2 squared. Let's call that 4. So c is negative 4. Agreed. So we're going to write our equation, natural log of the absolute value of y. So now let's go talk about y. We know that this particular solution is going to go through y equals 1. So it's defaulting to be positive. So natural log of y 1, positive 1, makes that positive y. Natural log y equals x squared minus 4. How do I solve for y? E. So y is equal to e to the x squared minus 4. Y or g of x. I think they would prefer g of x. I would prefer g of x. What do you think? Not too bad? No? All right. Now we've got, this is where I left off the other day and y'all yelled at me. They were easy until you left us alone and then we got cosine. I heard that. Okay, how do we want to do this? Can you kind of look at it and see what's going to happen? Do we have to write out all the separation of variables business, or do y'all see kind of, I'm going to divide by that square root 7 minus 2y. I'm going to multiply by dx. So I'm going to have dy over square root 7 minus 2y equals cosine of 2x dx. And now when we go to integrate, enter our this one. Are we kind of making some headway? So I did u sub on the right side. U is 7 minus 2y. So du is going to be negative 2, the left side. Negative 2 dy.
Sorry.
Well, I mean, if y'all aren't keeping track, who is? Because clearly I cannot. I don't want to call it 1 over square root u. I'd rather it be u to the negative 1/2 du. Are y'all okay with that? I don't have to change worlds here. I'm going to have to go back to my x stuff in the end because there's no worlds to change, which means I better dance with the one I brung. Cosine of 2x, we're going to have to u sub on this side too. U is 2x, du is 2 dx. So we've got a half on this side as well. Yeah? Any questions? I killed the halves. I don't know if y'all want to do that or not. We can keep them for now. I'm sorry. Add 1 to the negative 1/2. So I'm going to have u to the 1/2 divided by 1/2. So times 2 over 1. U to the 1/2 equals 1/2. What's the integral of cosine? I guess sine, cosine, negative sine. Need like blank paper. I don't have room. So I've got negative u to the 1/2 equals half sine u plus c. But I've got different u's. I probably should have used a different variable. Oh well. I don't have room. I need room. Negative, what was u over here? 7 minus 2y. Negative, open parentheses, 7 minus 2y to the 1/2 power equals 1/2 sine of 2x plus c. I'm going to get blank paper. Yeah. What's our initial condition? 0, negative 1. So when y is negative 1, negative 2 times negative 1 is plus 2. 7 plus 2 is 9. Square root of 9 is, so negative 3 equals, what's sine of 0? 0. Half of 0? Negative 3 is c. See, we get the heebie-jeebies, but it's not bad. You want to walk back through that? You good? I got this to be 0. Got this to be 9. Okay. So we got negative, open parentheses, 7 minus 2y to the 1/2 power equals 1/2 sine of 2x, close parentheses, minus 3. Solve for y. So I would divide by negative 1, which just means I'm going to flip every sign. So 7 minus 2y to the 1/2 power is negative 1/2 sine of 2x plus 3. And then square both sides. And then do we agree? If you turn your head sideways, do you agree? How's this going? We're okay? Okay. So the next one is a typical AP question. This is from 2008. Free response. 2008. I was a senior. Shout out to the class of 2008. My classes. Probably in prison. It's fine. All right, number 5, except for Juan's not. He's good. We kept him. Okay. Roscoe America. Yeah. Roscoe Plow Girls and Plow Boys. 20.
15 boys and
5.
5 girls. Wait, you and Juan went to the same school?
Mhm.
Oh.
We met in 7th grade.
Oh.
I know long time.
That is so sweet.
We were 12.
Oh, really?
Okay, consider the differential equation. dy dx equals y minus 1 over x squared, where x is not 0. On the axes provided, sketch a slope field for the given differential equation at 9 points indicated. Everybody breathe. Here's one tip, pro tip. What happens if y is 1? It zeroes out the top, right, which zeroes out the fraction. So there's your, we got that and that and that. That's helpful. You're welcome. Okay, y'all graph this slope field real quick. Okay, so we're moving on to part B. Find the initial condition within, whatever. Do the thing. Choose 0 is the point. So we're going to separate our variables. This is going to be dy over y minus 1 equal to dx over x squared. You could use sub right here just to be sure, but if you do find the derivative of y, it's 1. So du is dy, so you're really okay without it. Nothing's going to happen to you that's weird. So when we integrate both sides, we're going to get natural log of the absolute value of y minus 1 equal to, and consider that x squared as x to the negative 2 power. Add 1 back, that's going to be x to the negative 1 divided by negative 1. So negative, maybe 1 over x. Plus c. And at this point right here, plug in. So we have the natural log of 0 minus 1. Absolute value. Guys, throw those absolute value. You're going to think those are not important, but right here it's going to make all the difference. Because if I don't have them, I'm undefined. Natural log of negative 1 does not exist. But if I do have them, like I'm supposed to, natural log of absolute value of negative 1 is natural log of 1, which is goose egg. You see how that can make or break you? So we're going to add a half to both sides. So c must be 1/2. So now we go back and we solve for y. This is natural log absolute value y minus 1, negative 1 over x plus 1/2. Oh, she's doing her nose up. What would you do here? Yeah, e to the stuff. You're good. So absolute value of y minus 1 equals e to the negative 1 over x plus 1/2. And what do we know? If y is 0, we've got up, huh? See, I could go either way on that. I agreed, and then I looked at the solution, and they said it was negative. And I made a note in here to ask you guys what you thought. 2, 0 is going to go through 2, 0. They picked the negative option. So they say negative y plus 1 equals e to the negative 1 over x plus 1/2. We may have to dig a little further. For now, let's just go with it. I'll try to dig a little deeper and see what I can find out about that. I didn't have time. And then we would subtract the 1, and then we would divide by negative 1. So y is going to be negative e to the negative 1 over x plus 1/2 plus 1. Freeze right there, okay? Don't put up. Hey, y'all chill. We've still got 5 minutes, and we've got 5 minutes of work to do. 3 minutes. 3 minutes. Part C says, find the limit as x goes to infinity of this function. been a while. So we're going to look at it. The limit as x goes to infinity. That means that I plug infinity for x here. What's 1 over infinity? If I divide 1 into infinitely many pieces, how big are my pieces? Really, really small, right? So that zeroes out that piece. So really all that happens when we zero out that piece is then we have negative e to the 1/2 plus 1. It's not scary. You just zero out that little piece. As we take x to infinity, that piece of that exponent goes to 0. So the answer here is 1 minus square root e for the limit as x goes to infinity. And see, y'all would have skipped that. You got to the free response and you read limit and you just threw your pencil and quit. And this is easy. Just plug in 0 or plug in infinity, see what happens. Cool? Okay, now we can be done. See? So there is a homework packet that goes with it. You can work on that.